So previously we discussed about what is analog, what is binary, and the difference between binary and code conversion and everything. So this video we are going to discuss about classification of binary codes. So before start the topic, so we should be know what is code. Code is nothing but it's a group of symbols. So that is called as code. So what about binary code? So binary code means there is nothing but there's a digital data. It can store and transmit with a group of binary bits. That is called as binary code. An advantage of binary code. The advantage of binary codes are it's suitable for computer applications and it's for mainly digital communication purpose. We are using binary codes. Also, the binary code it can use that to analyze and design the digital circuits. And we know that it's only zeros and ones, so only two levels are there, so we can easily to implement this binary code using these zeros and ones. Classification of binary codes. There are so many categories. So here weighted codes, non-weighted codes, binary coded decimal code, alphanumeric codes, error detecting codes, and error correcting codes. So first, what is weighted codes? Weighted codes are, you know, weighted codes is also binary codes, which means it obey the positional weight principle. So that is called as weighted codes. So decimal, for example, the decimal number is 24. So you see, the two for binary code is 0100. For 4 binary code is 0010. So for 4 it is 0010. But everyone having the positional weight, and here this code have the positional weight, like that. This 2, this 0 having 1, and this 0 having 2 positional weight, and this one having 4, and this one is 8. Then the positional weight will be moved to like after 1 2 4 8 16 32 64, like that the positional weight will be moved from left to right. Even see the same positional weight also here because it started from 1 2 4 8. So wherever the positional weight having 1 representing 1, for example this 4, the positional weight it's upon the binary digit 1, so other things are 0. So similarly here also they're having positional weight, so the positional weight is below is 1, so remaining things are 0. So wherever the 1 is present, so that we can add with that total for calculating total decimal number. So this is only the 1 is presenting upon the 4, so the value of decimal number is 4. Similarly here the positional weight is 2, that is upon the code of 1 digit, so the 2 only the presenting, so automatically the 2 you will be get the decimal number. So this is weighted codes. So this total operation representing weighted codes. Non-weighted codes means there is no positional weight assigned to that number, that is called as non-weighted code. So the non-weighted code exactly given the example is XS3 code, gray code. So these are the example for non-weighted code. So XS3 code. So what is XS3 code? It is nothing but there is a binary number you just add with the 3. Then that is called as XS3 code. And this code doesn't have the weight of the code, so it is non-weighted code. Example, see the example. So this 0 1 2 7 8 9, so this is the decimal number. And BCD, so BCD started, the number is 0 to 9. So after 9, 10, 11, 12, there is invalid BCD numbers. Only 0 to 9 only valid BCD numbers. So here just they adding plus 3. So started from 0 0 0 0. Okay, so 0 0, just we just add 3. So you will be get the value 3. So 3 binary number they put it here, that is extra 3. So similarly here this is 1, so plus 3 added, so again the number will be, you will be get it. So similarly every number they having, they we just add 3 number, then that binary number will be present here. That is the equivalent of BCD. So this is excess 3 number, and this is a non-weighted code. And gray code, gray code means it's a mirror code. Mirror code we already discussed in previous video. How they saying mirror code? Yeah, see zeros and ones, you have to put the mirror here, and the mirror will be get it 1 0. So write 0 and 1 and put the mirror here, and you will be get it 1 0. So similarly 0 1, write it, so the total place is over 0 to 9. So if it is 0 to 15, you have to write up to 0 to 15. So similarly 0 0 1 1, so write it, so put the place the mirror here, then you will be get reflected 1 1 0 0. So 0 0 1 1, you have to write up to 0 to 15. So next one, double 0 double 1, then you have to place the mirror, then it that will be reflect. So this is nothing but like mirror we are placing, then you will be get the completed code, that is called as gray code. And binary coded decimal BCD code. BCD, binary coded decimal BCD code, so this decimal is started from 0 to 9. So this is BCD numbers they placed here. I guess see, so this is the numbers. Advantage of binary coded decimal, it's very similar to decimal number, only the binary equivalent started from 0 to 9 only. And drawback, it's additional and subtraction BCD have different rules. Okay, that's a big drawback. And BCD arithmetic is little bit more complicated, and BCD number need binary represented and less efficient than binary. That means BCD number bits are binary representing. The BCD is less efficiency than binary. And next one is alphanumeric codes. Alphanumeric codes, the name itself saying, so what are the things present in the codes? Alphanumeric means alphabetic, A to Z, so alphabetic, the total 26 alphabetic letters. And numeric means 0 to 9 numbers. So both will be present, and that will be make the code, that is called as alphanumeric codes. So alphanumeric codes, it's mainly used for that 0 to 9 and plus 26, totally 36 items they used for making the code. And it's mainly used for data representation. Because that zeros and ones only present in binary code, but that is not enough for good communication. So they need more symbols, more numbers for good communication. So that's why they are moving to alphanumeric codes. So then another codes, American Standard Code for Information Interchange, that is nothing but ASIC code. Then extended binary coded decimal interchange code, ABCDIC. Then 5-bit Baudot code. Then ASIC code, that is totally 7-bit code, and this ABCDIC code is 8-bit code. And this ASIC code mainly used for that value they are using, and that ED that extended binary coded decimal interchange code EBCDIC code that mainly used in IBM computers. So large IBM computers. Next one, error codes. Okay, so the binary codes techniques available. This is mainly for detect and correct the data during the transmission. So this is called as error codes. So this mainly used for detect and correct the data during the transmission. So there are two types. One is error detecting codes. Another one is error correcting codes. So first of all, we have to know what is error. Error means it's a condition when the output information does not match with the input information during the transmission. So that is called as error. So error is nothing but the output information does not match with the input information during the transmission. And 0 bit change 1 to 1 may be changed to 0. Okay, the computer 1 and computer 2 is there. So computer 1 sending the data transmission, digital data transmission. You see that binary signal is moving from sender to receiver. In between the noise are occurred. So in the, due to the noise the signal is varied, you know. See the signal, how the signal is varied. So this is the sending signal, binary signal, and due to noise the signal is changed. So interface network problem. Okay, so this is computer to receive only this kind of signal because of adding noise, or that is error. And error detecting codes. So we know what is error, and now we are going to see what is error detecting codes. Error detecting code, that means it's additionally data is added, and that data it is not a record one. That means simply, that additional data, a given message that error occurred during the transmission, so that is not needed by the users. That is called as error. That is the data is added in the original signal. And error correcting codes. So this is the example for parity check for error detecting codes and error correcting code. So we know what is error, and we can using error detecting codes using parity check. And error correction means then the that additional data will be detected, and we have to where it will be error that will be detect, and then correct that error. So that is called as error correcting codes. So once if you found the correct bit location, the value will be reverted, because in digital might be 0 or 1. If there is a error that is detected there, if it is 0 is there, we have to convert as 1. Then again, if there is a error we are detected at that place, then we just convert it into 0 if it already present 1. So this is the way they have to correct the error. So additional, how they will be detect and correct the errors they saying. Correct errors we just know we discussed, and detect error is nothing but just we add the bits, and that additional bit added, that is nothing but parity bits. And additionally we are adding bits, that is called as parity bit. So they allow detection or correction of the errors. And parity bits from code word, and parity checking for error detection. This we will see in next video. Thank you.